everyone. Welcome to A1 Tutor live class, and we'll be having mathematics. Once again, welcome to our live class. Today we are going to be discussing a new topic, and the topic we are going to be discussing actually gave birth to this picture we have on the screen. I believe everyone can hear me. If you can hear me, please kindly signify or type yes or thumbs up. All right, thank you for your responses. So today we are taking a new topic, and the topic we are going to be discussing today has to do with this picture. Now we have a picture here. I believe you can see what is on the picture. We have here the statement "Orang now, this thing no equal." So who can actually even guess the topic? If you can guess the topic for the class today, with this statement that we have here, "Orang now, this thing is not equal now." So what do you think could be the topic? Inequality. All right. So today we are discussing the topic that has to do with equality. Equality. Now, we see this picture has two people, two individuals. Of course, both of them are adults, and they were served food in an occasion. And what you could discover is that Mr. A, which is this man, Mr. A and Mr. B. Mr. A was served the largest portion of the food with chicken and everything as you have in the picture. And Mr. B was served same thing as rice, but a small quantity and with a small chicken. And Mr. B has to shout, "Hold on now, this thing is not what? Is not equal." Meaning that the food of Mr. A is what? Is greater than that of Mr. B. And the food of Mr. B, that means A is greater than B, and we can say what? B is less than A. And this gives birth to what we call inequality. Okay? When you have an expression that is not actually having the same quantity, it leads you to what we call inequality. That is, one can be greater than the other, or one can be lesser than the other. I believe you understand what I'm saying. So this picture gives us the introduction of today's topic, which is what? Inequality. Inequality. All right. I believe you are with me. So now let's dive into the topic proper. I'm going to stop presenting this picture. Let's dive into the topic proper. So I said we are discussing the topic inequality. Inequality. All right. So today we are discussing the topic inequality. If this is the first time that you are watching our video on YouTube, please take a pause and do well to subscribe on our YouTube channel. That's very important. Subscribe and try to comment, try to also share our videos. Okay, thank you for that. And let's continue. Inequality, like we said, that when we have quantities that have a different kind of quantities, we have probably two quantities, but their measurements are kind of different. That means one can be greater than the other, and one can be lesser than the other. So if we have that kind of condition, it takes us to the topic inequality. Okay, and inequality is taken from the word equal. From the word equal. All right, so it is attached to the word equal, and that's why we have in, then we have equality. Equality has its own meaning. That means things are what are the same, or things are actually the same thing in size, in quantity. But when you have the prefix, in, it gives it another meaning, inequality. So that's just a normal English. All right. Now, When we talk about inequality, we are talking about some signs that are different from the equal sign. We are talking about some signs that are different from the equal sign. And what are those signs? Because you have to understand the sign before you can solve questions on inequality. So that will take us to the first outline, which is the inequality sign. The inequality sign. The inequality sign we have is we have the less than, we have the less than, we have the less than, we have greater than, we have less than or equals to, less than or equals to. We also have greater than or equals to, greater than or equals to. We also have greater than or equals to, less than or equals to. Those four signs are going to be the major thing we'll be focusing on today. These four signs are going to be the major one we're going to focus on today. So we have the less than, the greater than, the less than or equals to, and also we have the greater than or equals to. So these are the four inequality signs we are going to focus on today for the class. All right. So these are the inequality signs. Now we have to move on to the next subtopic under the topic inequality, which is inequality of one variable or inequality in one variable. Inequality in one variable. Before we proceed to that, let me make a kind of category. Let me categorize the inequality sign. You see these two inequality signs, they are called the strict inequality sign. They are called the strict inequality sign. Why these two are called the weak inequality sign? Okay, these are called the strict inequality sign, and these are called the weak inequality sign. So inequality sign is categorized into two. We have the strict inequality sign and the weak inequality sign. All right. Now let's proceed to the aspect that has to do with inequality in one variable. Inequality in one variable. All right. Inequality in one variable. Okay. Permit me to wipe the board. We are moving on to the next item, which is inequality in one variable. Inequality in one variable. Inequality in one variable. So inequality in one variable has to do with an inequality expressions that deals with only one variable. In our previous classes, I said that a variable is an alphabet in mathematics. Alphabet like A, X, Y, Z, they are all what? Variable. They are all variable. But for this topic, inequality, we are going to focus the more on letter X. We are going to focus the more on letter X. All right. So now let's take the hints, because when you are solving inequality, if you don't have the knowledge of what you are doing, you might actually solve, and on getting to the final answer, you will make some slight mistake. So there is a very cogent and important things you have to know about solving inequality, either in one variable or probably in another kind of question. The information or the hint is that when you multiply, when you multiply or divide both sides of an inequality expression comma, the sign which is the inequality sign, let's put it that way, the inequality sign changes. The inequality sign changes. Okay, when we multiply or divide both sides of an inequality expression by a negative integer, inequality expression by a negative integer, the inequality sign changes. All right. So when you multiply or you divide both sides of an inequality expression by negative integer, the inequality sign changes. And this is just an illustration. If I have minus 2x is less than 4, minus 2x is less than 4. Now I'm to divide both sides by minus 2, which is the coefficient of x. I'm to divide both sides by minus 2, which is the coefficient of x. Then I'm going to have minus 2x over minus 2. Because I'm dividing with a negative integer, this sign will change from this to this. All right? It will change from less than to greater than. That is the hint. It is changed from less than to greater than. So I'm going to have greater than 4 divided by minus 2. Of course, let the minus be at the numerator, not the denominator. So let me take away minus from here. So I'm having this expression. I'm having minus 2 cancel minus 2. X is greater than minus 2. So the answer will be x is greater than minus 2. Now, what do you notice? We divided both sides by minus 2, which is a negative integer. And the sign changed from less than to greater than. The sign changed from less than to greater than. So it is applicable also when you multiply. Let's take that also. Let's say we have minus x is less than, okay, this time around we use greater than or equals to 1, minus x is greater than or equals to 1. Following this code or following this hint, if I multiply both sides by minus 1, which is a negative integer, the inequality sign must change. Okay, so if I have minus 1 in bracket minus x greater than, okay, instead of greater than now, because I'm multiplying by minus 1, my sign will change from greater than to less than or equals to 1 multiplied by minus 1. What do you notice? I multiply both sides by minus 1, minus 1. So that has led to the inequality sign to change. Okay, so we'll be having x is less than minus 1. That will be the what? The final response. X is less than minus 1. So I believe you understand the hints now, because we'll be working with these hints from the beginning of the class to the end of the class. Can we proceed? If you are with me, can we proceed? All right. So thanks for your response. Now let's go ahead to take some questions. Let's go ahead to take some questions on inequality in one variable. Inequality in one variable. So permit me to wipe the board. Still on inequality with one variable or in one variable, linear inequality in one variable. Now we'll take a question on that so we can explain better. Let's solve this question together. Solve 6x minus 14 is greater than or equals to 13x. I believe you are with me. Can you see the board? All right, so let's go ahead to solve. Solution to this question, 6x minus 14 is greater than or equals to 13x. Now, have this in your mind that when you are solving inequality, it's just as if you are solving a normal algebraic equation. So when you are moving a variable or you are moving a number from one side, crossing the inequality sign, it has to change. The sign has to change. If I have minus 2 plus x is greater than, let me say 4, if this minus 2 is crossing the equal sign, I'm going to have x is greater than or equals to 4 plus 2 is applicable to what we do in algebraic equation, okay? When 2 crosses the inequality sign, the sign of 2 also will change from negative to positive and from positive to negative. I believe that is clear. Okay, now let's solve this. We need to first collect the like times for this expression. We need to collect the like times. So what do? We take this 13 from this place inside here, and we'll be having 6x minus 13x. Because 13 was positive, when it crossed the inequality sign, it becomes minus 13. All right, now we have greater than or equals to. When you take also minus 14. When you take minus 14, to cross the inequality sign to this place, we are going to be having plus 14, or you say 14. You have what? 14. So minus 14 has changed to what? 14. I believe that is clear to us. Okay, now let's proceed. Subtract 13 from 6x. Subtract 13x from 6x, and that will give you minus 7x. Minus 7x is greater than or equals to 14. Is greater than or equals to 14. Now, I want to ask the question. To get the value of x, we are going to divide both sides by what value? We'll be dividing both sides by what? I need your response in the chat box while the class continues. We'll be dividing both sides by what? To get the final expression, we have to divide both sides by minus 7. Minus 7, because minus 7 is the coefficient. This is the coefficient. So we have divide both sides by minus 7. So we have minus 7x over minus 7. Now, because we are dividing by minus 7, okay, follow, minus 7. When you divide by minus 7, it means that you are dividing by a negative integer. You are dividing by a negative integer. So dividing by a negative integer, you are going to have the inequality sign to change from greater than, or equals to less than or equals to, because I am dividing by minus 7. All right. So this we have 14 divided by minus 7, but it is not allowed to have your minus at the denominator. Bring it to the numerator. So here you are going to have minus 7, cancel minus 7. Then you have x. You have x is greater than, oh sorry, x is less than or equals to, x is less than or equals to minus 2. X is less than or equals to minus 2. And that will be the final answer for this expression. I believe that is clear to us. I believe that is clear to us. Okay, can we proceed? Can we proceed to the next question? Now let's take the second question under that. Permit me to wipe the board while we are taking the second question under linear inequality in one variable. We are still under linear inequality in one variable. Linear inequality in one variable. Now let's consider this question. Solve 1/3, open the bracket, 2x minus 1, okay, less than 5. So this is the question we want to solve. In this case, now we have a bracket in the question. So following the rule of BODMAS, you need to first deal with the brackets. But before that, we have a fraction. We have a fraction, and that is 1/3. So we are to multiply through by the denominator of that fraction. What is the denominator of that fraction? The denominator is 3. So you say multiply through by 3. Multiply through by what? 3. So you have 3 in bracket, 1/3. Open another bracket, 2x minus 1, close bracket, less than 5 times 3. Now what I've done is that I multiplied that question by 3 because 3 is the denominator of the fraction. So I multiplied it by this 3. I also multiplied this side by the 3. So both sides were multiplied by 3. Okay, that will enable us to eliminate the fraction in that question. It will enable us to eliminate the fraction in that question. So if I proceed, I'm going to have these 3 cancel 3. These 3 cancel 3, and you have 1 left into bracket 2x minus 1, close the bracket, less than 5 times 3 is 15. 5 times 3 is 15. All right? Using 1 to multiply the bracket, you still have 2x minus 1. 2x minus 1 is less than 15. Now what next? We need to collect the like terms. We need to collect the like terms. So if this guy, which is minus 1, cross the inequality sign, what is going to be the answer to write at the other side? I need your response in the chat box. When minus 1 cross the inequality sign, we are going to have plus 1. Plus 1. Thank you for your response, Emmanuel. So we have 2x less than 15 plus 1. 2x less than 15 plus 1. So we have 2x less than 15 plus 1 is 16. So we need to divide both sides by the coefficient of x. Divide both sides by, what is the coefficient of x? The response in the chat box. What is the coefficient of x? What is the coefficient of x? The coefficient is 2. The coefficient of x is 2. Thank you for your response, Emmanuel and Jane. Thank you for your response. So we have 2x divided by 2 is less than 16 divided by 2. So we have 2 to cancel out 2. X is less than 16 divided by 2 is 8. So the answer is 8 is less than, oh sorry, the answer is x is less than 8. X is less than 8. I believe that is clear to us. If yes, please kindly react so that we can move on to the next. All right, thank you for your response. Can we proceed? So now we are going to examine the inequality combinations and ranges. The inequality combinations and ranges. The inequality combinations and ranges. All right, so permit me to wipe the board. Permit me to wipe the board. Enoch, I believe you are following and you are getting what we are solving. So on to the next, which is inequality combinations and ranges. Inequality combination, inequality combinations and ranges. Inequality combinations and ranges. Now, what we are going to be doing under this subtopic is to get the range of some inequalities given to us. All right, to get the range of inequalities that will be given. Let's take the first question on that. If x is a positive, if x is a positive integer, if x is a positive integer, comma, list the values of x, is the value of x which satisfy the equation, which satisfy the equation 3x minus 4 is less than or equals to 6, and the second one is x minus 1 greater than 0. X minus 1 greater than 0. Okay, so let's solve that question. Let's solve that question. Now, to solve this question, we need to handle those inequalities separately. All right, we need to handle the inequalities separately. So we have the first one to be this, and the second one to be this. Okay. Now back to the question that we are solving. We have 3x minus 4 is less than 6, and x minus 1 is greater than 6. We are asked to find the what? The positive integer. The positive integer that has to be the value of x that will satisfy these two inequalities. All right. So if you are going to get the value that will satisfy the two inequalities, we need to solve them together. Okay. We handle them separately, then we'll bring their responses together. All right. So let's do that. We'll divide our board so we have enough space to solve. undo the first inequality, which is 3x minus 4 less than or equals to 6. By collection of like terms, if this guy, which is minus 4, moves to this place, we are going to have what? I need your response in the chat box. When minus 4 cross the inequality sign, what are we going to have at the other side? Your response, 3x will be less than or equals to 6. Your response should be plus 4. Your response should be plus 4. All right? 3x less than or equals to, adding 6 to 4, that is what? 10. That is 10. Now, to get the value of x, we need to divide both sides by the coefficient of x. Now, what is the coefficient of x? I leave that to you. What is the coefficient of x? Your response in the chat box. What is the coefficient of x? 3. Thank you for your response, Jane. The coefficient of x is 3. So I'm to divide both sides. I'm to divide both sides by 3, and that will give me 3x divided by 3 less than or equals to 10 over 3. Okay? If you notice, the inequality sign did not change. The inequality sign did not change because I divided both sides by a positive integer, which is 3. So it will not affect the inequality sign. The inequality sign will be affected only when you divide both sides by a negative integer. When you divide both sides by a negative integer. All right? So we divide this. 3, we cancel out 3. 3, we cancel out 3. And you'll be having x is less than or equals to 3.333. But for the sake of this question, we are going to stick to an approximate value, which is x is less than or equals to 3. So I want to have it in the nearest whole number. So the nearest whole number of 3.33 is going to be what? 3. So I've solved this one. I've solved this particular inequality. Now let's solve the second one. Then when we are done solving, we'll bring their response together. X minus 1 is greater than 0. X minus 1 is greater than 0. By collection of like terms, if this girl moves to the other side, minus 1 moves to the other side, we are going to have what? What are we going to have in the other side? Response. What are you going to have in the other side? Plus 1. Thank you for your response, Emmanuel. So we have x is greater than 0 plus 1. 0 plus 1. All right? That is x now is greater than 0 plus 1 is 1. 0 plus 1 is 1. Now we are done solving this also. The last thing to do is to bring the two responses together and have it as a range. And have it as what? As a range. Okay? So the first one we solved, we got x is greater than, or sorry, x is less than or equals to 3. And we have x is greater than 1. All right? Now we want to have it as just a single range. Okay? When I say a single range, I mean something of this nature. A is less than x, less than b. This is what we call range. Combined range. Okay? Now, to do that, you have to be very attentive at this moment. We have 3, and we have 1. Between 3 and 1, which one is lesser? Between 3 and 1, which one is lesser? Which one is smaller? I need a response. Between 3 and 1, 1 is lesser, right? That means I'm going to write 1 first. I'll write 1 first. I will say the symbol, check the symbol of 1 here. It was greater than, okay? So I'm going to change it to less than, but I'm not going to add any stroke under it because here it was not having any stroke of equals to. All right. Now I'm done with 1. Then I'll put x because the variable we are working with is x. Now, if 1 is less, that means 3 will be the next one that is bigger, right? So now you're going to have the sign for 3, which is less than or equals to, less than or equals to, that's from 3, and you have your 3. So this now forms the range of the value for x. That means x has to be in between 1 and 3. X has to be in between 1 and 3. And if I'm asking you to list out the values between 1 and 3, okay, what are going to have as those values? What will be the value between 1 and 3? Between 1 and 3, numbers that are less than 3 and also less than 1. Take note, 1 must not be included. 1 must not be included. So what are those numbers? Number in between 1 and 3 is 2, and 3. 2, and 3. Now, the reason why 1 is not included is because we have a what? A strict inequality sign. I told you earlier that this means a strict inequality sign. Strict. So it's saying that 1 should not be part of the numbers. But when you have this, it is a weak inequality sign. Weak. When I say something is weak, that means it does not have strength enough. So it means the weak inequality sign, we allow 3 to be part of those numbers. And that is why 3 was what? Was listed out. I believe that is clear to us. Is this question clear to us? Can we proceed to the next question? All right, so let's move on to the next question. We are still on range. We are still on range. We'll take one more question on that. Then we'll move to the next subtopic. So let's consider the second question under range, under combinations, and range. So permit me to wipe the board. Permit me to wipe the board. Now we have question 2, still under inequality combinations and range. Find the range. Find the range of values of x for which 2x minus 1 less than or equals to 3 and 2 minus x less than or equals to 5. Okay, for which these two inequality will be satisfied. The value of x. So we need to divide the board into 2 like we did the other time, and we'll be solving separately. All right, so let's go ahead to solve this first. The first inequality, let's handle this. 2x minus 1 less than or equals to 3. By collection of like 10, when you take this guy to the other side, you are going to be having 2x is less than or equals to 3 plus 1. That is 2x is less than or equals to 4. So I need to divide both sides by a positive integer, which implies that my inequality sign will not change because 2 is a positive integer. 2 is a positive integer. So dividing both sides by 2, divide both sides by 2, we are going to have 2x divided by 2 less than or equals to 4. divided by 2. If minus cancel minus, or sorry, if 2 cancel 2, if 2 cancel 2, you have x is less than or equals to 4 divided by 2 is 2. 4 divided by 2 is 2. Okay? 4 divided by 2 is 2. So we are done with the first inequality. Let's dive into the second one. This, we need to solve this also separate. 2 minus x less than or equals to 5. 2 minus x less than or equals to 5. By collection of like term, if this guy, which is plus 2, is going to the other side, you are going to be having minus x, because the minus belongs to x. The minus belongs to x, not to 2. The sign that belongs to 2 is plus, and that is why when 2 plus 2 cross the equal sign, I'm going to have minus 2. I'm going to have minus 2. So minus x now is less than or equals to subtracting 2 from 5, that is 3. Now, this cannot be the final answer actually, because when you are solving an inequality question, you are expected to solve for x, just like we are solving an equation. So minus x is not completely solved. It has to be x. X. It must not have any sign. It has to be the variable x. So how do we take away the minus? Of course, it's either we divide both sides by minus 1 or we multiply both sides by minus 1. Okay, but this time around I'm going to use multiply both sides by minus 1. Multiply both sides, multiply both sides by minus 1. Multiply both sides by minus 1. That is minus 1 in brackets minus x. Okay, now because I'm multiplying by a negative integer, you have to take note of that. Because I'm multiplying by a negative integer, my inequality sign must change. My inequality sign must change. So it's going to change from this to greater than or equals to. Greater than or equals to. And it is so because I multiplied both sides by minus 1. So have it in mind that anytime you divide by a negative integer or you multiply by a negative integer, you are going to have the reverse of your inequality sign. Okay? The reverse of your inequality sign is what you are going to have. So this, we are going to have minus 1 also in brackets, then 3. Minus cancel minus, 1 times x is x. X, okay, is greater than minus 1 times 3 is minus 3. So x is what? Greater than or equals to minus 3. X is greater than or equals to minus 3. Now, let's combine the range together. Let's combine the inequality response together to have a range. All right? So to do that, you have to, again, compare the two responses between 2 and minus 3. Which one is lesser? Between 2 and minus 3, which one is lesser? I need your quick response in the chat box. Between 2 and minus 3, which one is lesser? Quick response, okay? Minus 3 is lesser. Thank you for your response, Emmanuel. Minus 3 is lesser. That means I'm going to write minus 3 as the first number. Minus 3, okay? Now, after writing minus 3, I will check the inequality sign. It was greater than or equals to, but now I'm going to have it as less than or equals to, because I still have another number to include in the range. Okay, it's going to be less than or equals to x, which is the variable we are solving for. Now you move on to 2. And before you can write the 2, you must have the sign of inequality also, which is less than or equals to what? 2. Less than or equals to 2. So we are saying the numbers that we are going to have are numbers in between -3 and 2. And both of the inequality sign are weak inequality sign. They are weak inequality sign. So what are we going to have as the numbers? Can we list them out? We are going to have -3 will be part of the numbers because I have a weak inequality sign. After -3, I will have -2, -1, 0. Okay, can you tell me the remaining two? The remaining two numbers we are going to have, I've listed -3, -2, -1, 0. So, okay, thank you, Emmanuel. 1 and 2. So all these numbers are the what? Are the range that we are going to work for. So x can be any of this number. X can be -3, x can be -2, x can be -1, x can be 0, and x can be 1, x can be 2. All right. So if you insert any of this value here, it's going to satisfy this information here. Okay, it's going to satisfy the information here. Is that taken? Now let's try one. Let's try one. Let me use this. I have 2 minus x less than or equals to 5. Let's say when x equals to -3, when x equals to -3, that is 2 minus, in bracket, -3 less than or equals to 5. 2 minus times minus is plus, that's 3, less than or equals to 5. 2 plus 3 is 5. 5 is less than or equals to 5. Is this expression valid? 5 is less than or equals to 5. Is it valid? If it's valid, say yes or thumbs up. If 5 is less than or equals to 5, a valid expression, thank you for your response, is valid because we have equals to. He said 5 is less than or equals to. That means 5 is equals to 5. You get that? So anytime you solve questions like this, you can test with the values to see if they satisfied the inequality expression you are given. If they do not satisfy the inequality expression, that means you need to check your solution. All right. So this is the second question under inequality combinations and ranges. All right. So if this is clear to us, please let's signify. We are moving on to the next. Okay. Thanks for your response. Now let's move on to a graphical representation of inequality. Graphical representation of inequality. While you in GSS, you did what we call number line. And I think in GS3, there's a topic that has to do with number line. Even under the topic number line, you did something like directed number and non-directed number. Okay. So from there, the knowledge of graphical representation of inequality comes from representing your inequality answer on a number line. And that is called a graphical method. That is called a graphical method. So let's look at the 4 or 6 possible graphical representation of inequalities. Now we are going to graphical representation of inequalities. Graphical representation. Graphical representation of inequality. Graphical representation of inequality. Of inequality. So we have like 6 cases under that. So I'm going to discuss the 6 cases for us. We're going to take it one after the other. The first, if I have A is less than X. Now take note that A can be any number. A can be any number. All right. or better still, let me write it in this way, that x is less than a. X is less than a. Then a can be any number. So on the number line, I'll draw the number line. It has a neutral point, which is 0. And this place you have minus a. And this place you have a. I said take note that a can be any number. So I'm just using a to explain this diagram. Okay. Now, how do we represent this on graph? How do we represent this on graph? You first have to identify a. So if I identify a, this is a, I'll make a kind of a small circle on it. Now, when you are dealing with less than, to which direction do you move? Take note, when it is less than, you move to this direction, less. When it is greater than, you move to this direction, greater. Okay, so take note of these two arrows. Less than is going to this direction, greater than is going to this direction. Okay, so because this is dealing with less than a, the direction will be in this way. So this is going to be the graphical representation of x is less than a. Take note, a can be any value. It can be x is less than 4, that means a is 4. It can be x is less than 7, that means a is 7. Now, you can see that the a is at the positive side. This place is negative for the negative integer, and this place is for the positive integer, while 0 is the neutral. Is the neutral. It has no sign, whether positive or negative. It's not having anyone. I believe this is clear. If it is clear, let's move on to the second case. The second case, number 2, if I have x is greater than a, x is greater than a, you still have to draw the number line, okay, and indicate the neutral point, which is 0, indicate the positive side, which is a, and negative side, which is what? Minus a. Okay, this time around, let me use minus. Let's say minus a. Now, what's the first thing to do? The first thing to do is to identify minus a on the number line. Identify minus a on the number line. So this is minus a. This is minus a. Now, which direction is it going to? We are dealing with greater than. We are dealing with what? Greater than. So it will move to this direction. This is x is greater than minus a. X is greater than minus a. I believe these two is clear to us. The two conditions or the two cases, I believe they are clear to us. Okay, if they are clear to us, please signify. Now, let's take a pause. For those of you watching our video for the first time on YouTube, please, can you just take a little moment and click the subscribe button? Yes, click that subscribe button for you to have notifications of our video contents. Click the subscribe button and also do well to share our link to friends. Thank you as you are subscribing to our YouTube channel. Okay, now let's continue with the class. We have 2 or 4 more cases to go. So we are going to wipe the board. We're going to wipe the board and take the third and the fourth case. The third and the fourth case. The third and the fourth case of graphical representation. Okay, now let's have the third case. When we have x is less than or equals to a. X is less than or equals to a. You first have to draw the number line, indicate the neutral point, which is 0, indicate the positive, which is a, indicate the negative, which is minus a. All right. Now, how do we represent this on the graph? First, you have to identify A. So A is on the positive side. Put a circle on it. Now you are dealing with the sign less than. And I said less than has to be in this direction. So I'm going to move the arrow to this direction. Is that all? No. Because we have less than or equals to, you need to shade your circle. You need to shade your circle. So this represents less than or equals to. Less than or equals to. I believe that is clear to us. Can we take the next one? Number 4, when x is greater than or equals to minus a, when x is greater than or equals to minus a, or draw the inequality sign, indicates the neutral point, indicates the positive, indicates the negative. All right. Now, you need to identify where minus a is on the number line. We have minus a here, and we are dealing with greater than. So greater than faces this direction. So the arrows go towards this direction. And because it is greater than or equals to, I need to shade this portion of my diagram. I need to shade this portion. All right. So this is the fourth case. This is the fourth case. Now let's take the two remaining cases, which will be number 4, number 5, and number 6. Number 5 and number 6. Number 5, we have A is less than X, less than B. We have two constants now, which is A and B. We draw the inequality line. We draw the number line. Identify the neutral points. Now we have both of them are actually positive. So let's say this represents A and this represents B. This represents minus A and this represents minus B. Now I need to identify B and A. So this is B and this is A. I need to join them together with a line. So this representation shows that A is less than X and less than B. A is less than X and less than B. And the last one, which is the case number 6, case number 6 is A less than or equals to X less than or equals to B, less than or equals to B. So we have to draw the inequality line, also known as the number line, indicate the neutral, indicate the positive A, positive B, the negative A, and the negative B. Let's make these two to be negative. This is negative. All right, one negative, one positive. Let's have it that way. One negative, one positive. So to indicate this on the number line, we first have to identify minus A. And this is minus A. Now identify B. This is B. Connecting the two together with your line shows that minus A is less than X, less than B. Now, to make it satisfy the expression less than or equals to, you need to shade this circle and shade this circle. So this means minus A is less than or equals to X, less than or equals to B. Minus A is less than or equals to X, less than or equals to B. Minus A is less than or equals to X, less than or equals to B. So this is going to be the representation of the what? The graphical representation of this expression. I believe that is clear to us. If yes, please kindly signify with your emoji. Thumbs up, thumbs up. Okay. Thanks for your reactions. Today we are going to stop here, and tomorrow we are going to continue the topic. We have been able to discuss the concept of inequality. We have been able to discuss the concept of inequality using a real life representation, using a real life representation, using a real life representation. This is what we use to explain the concept of inequality, that if this is Mr. A and this is Mr. B, that means Mr. A food is greater than that of B, and Mr. B food is less than that of A. So we've been able to discuss the concept of inequality. We also discuss the inequality in one variable. We discuss inequality combinations and ranges, and also we discuss the graphical representation of inequality. The graphical representation of inequality. So please do well to always subscribe on our YouTube channel. And for those of you that are watching our video on YouTube for the first time, please do not just watch, do well to click the subscribe button. It does not bite. Just click and click and click. Thank you for your time. Tomorrow we'll continue the topic. Bye.